every management will going to be done by this operating system. That is what this operating system is considered as a core of any of the computer. Whenever we are having a similar needs with similar requirements of resources, then we are making that number of jobs as a group, and we are calling that group as a batch. For each user, every resource will going to be allocated individually, but more than 2 person accessing a same system with a single OS, but individually they are accessing. Hello everybody, a warm welcome to one and all. Welcome back to the session 1 of chapter 2 in the unit 2 of B.Ca's first semester, subject called Fundamentals of Computers. I'm Rohini TS, Department of Computer Science, Vidhyaashram First Grade College, the Temple of Excellence, MYSURU. In this chapter 2 of unit 2, you will be learning regarding the operating system fundamentals. So we'll see the recap of our previous session. That's all regarding what chapter 1. In this, at the last session of the chapter 1, we had a discussion regarding computer memory. There you got to know what do you mean by computer memory and what are the classification, primary and secondary memory, along with the different classification of this primary and secondary memory. That what we had a last session in the chapter 1. So in our today's session, we're going to learn about the chapter 2. In that, first you will be learning what you mean by operating system. So then, what are the function it will going to perform? Along with that, we'll see what are the different types of operating system we have along with an example. First, we'll see what do you mean by an operating system. I can say that without an operating system, computer or any other machine is just a dumb machine. So why? Because an operating system will going to controls and coordinates all the activities of a computer system. That is why. And also, you know, the classification of software. In that we have a system software and application software. In the application software, we have a general purpose and specific purpose that is got over. When it comes to the system software, that is a fundamental part and a mandatory part of any of the software. Amongst that, operating system is also going to play a very important role in the system software. So here you can see the definition of an operating system. It's a set of program. If it is a set of program, then it is a software which acts as an interface. It acts as an interface between what and what? That is what? Between the user and the computer or any of the electronic devices. So here we are focusing on the computer operating system. So this operating system will going to act as an interface between the user and the computer component. For example, if you wanted to use a mouse, if you want to use a keyboard, all those are what? Computer components, and we are the user. We are getting a benefit from that. Without that operating system, we can't build a relationship between the user as well as to the computer components. That is what the reason operating system is considered as very important. And also, it's a system software is what operating system which starts up the computer and control its operating system or control its operations. This operating system will going to help the computer to turn it on. So for that purpose, this operating system is very mandatory, and also it has the controls and coordinates all the operation which we are doing in a computer. And also this will going to manage the resources. That resources can be time, memory, and also it resolves the conflicts. Why? Because it is controlling and managing all the operation. Whatever the conflicts arises in between, everything will going to be resolved by this operating system, and also it will going to try to optimize the performance of the system by managing the device, by managing the memory, by managing the files. Every management will going to be done by this operating system. That is what this operating system is considered as a core of any of the computer. And also the user communicates with the computer through this operating system commands and program instruction. Then how can I communicate to a computer? That too by making use of OS and then program instruction. By making use of these two, we can have a communication to the computer components. And also it's going to play a very important role in loading up programs from the disk into a memory. If we wanted to execute anything, that should be in a computer memory. Then movement of that data and programs from the disk into the computer's memory will be done by this OS, and also displaying the message, displaying the notification, everything will be handled by this OS, and translating the program and outputting the result. So all these are the different role or different operation which is going to be handled by this operating system. So here you can see the main function which is going to be performed by the operating system. Very important question. Define operating system and write the functions of an operating system. So in that, it is going to manage the memory. Memory management is also going to be taken care by this OS, and also it is going to manage the process, whatever we have in a computer program which is in execution. That is what process. That management is also by OS. And then device management, input output devices, any peripheral devices, inserting and deleting it, ejecting, everything will be handled by OS. And file management, deletion, creation, renaming, all the content with respect to this file is also going to be managed by OS. And also protection and security. It won't allow the unauthorized access. It is going to provide the security, and it provides only the accessibility to the authorized user. And also user interface or command interpreter. If I wanted to communicate to a computer, that can be GUI or CUI, graphical user interface, or command or character user interface. So that is also going to be provided by this operating system. Here you can see the first one. First is all regarding memory management. Management of memory is very important. Why? Because memory is considered as a resource of a computer system, correct? Then it is going to allocate the memory. Once it got over, that should be freed from the pool, or it should be kept back to the pool. That is what freeing of memory is also be done by this OS. Then reallocate the memory to program when used block is free. When we are freeing that used block, that should be stored in a pool or memory pool. Again, it will going to be reallocate the memory to the needed things. And also it will going to keep track of the memory usage. That is what the reason you all can see what is the memory used in your mobile phone. That is will be handled by this operating system. Next, what we have, process management. Program which is in execution is called process. That management of this process is also going to be very important. Playing of a music, pausing that one, and double tap, and if you are fast forwarding, all those are what process, which the program which is in execution is process. Then here, it is going to control the access to shared resources like file, memory, input, output, and CPU. So, all the processes which is going to be done by the different components of a computer will going to be controlled and managed by this OS, and then control execution of an applications. So, for example, sometime the operating system won't allow you to download certain application which are malware or malfunctioning is there. It is going to just give you the notification. So, it is a threat to your device. Would you like to continue? Yes or no? That is what it mainly will going to control the execution of application. And create, execute, and delete of a process is also going to be handled by this OS. Then cancel or resume process. Whenever you are pressing cancel or resume, pause, all these will going to be handled by OS. And schedule a process. For example, setting of an alarm and the setting of some schedules, meetings, all will going to be handled by this OS. Along with that, synchronization, communication, and deadlock handling for process. So, all these operations or management with respect to the process will going to take care by operating system. Next, here we have a device management. The device can be hardware and software, mainly open, close, and write device drivers. So, if you consider the hard disk drive, floppy disk drive, so all those needs to be controlled properly. So, for that, opening of that drives, closing of that drives, reading and writing of content from that disk, everything will be handled by this OS. Along with that, communication, control, and monitor the device drivers who all can access, and what are the communication establishing between the drives and disk, and also how to control along with monitoring of all the activities with respect to the device will be handled by this operating system. Next, here we have a file management. So, we are going to use a file in order to store the related data, right? And creation of that file, deletion of that file, as well as directories will be handled by OS. and then it will going to provide access to a file. If it is private file, then it can't be accessed. If it is a public file, overall the user. So that authentication and checking of accessibility to the file is also going to be provided by OS. Then allocate the space for file. Without memory space, we can't store the files or directories in any of the drive. So that the accessibility and allocation of that space or a memory for file is also important. Then keep backup of file. If something goes wrong in between the computer, or if some failures occurs to the computer, at the time backing up of that file is a responsibility of this OS. Then secure a file. So that should not allow any unauthorized access in order to access the confidential data. Next, what we have, the types of operating system. That's all regarding what? Operation which is going to be performed, or the functions of an operating system. So now we'll see what are the different types of operating system we have. We have single user operating system when it is used by single person. Then we have a batch operating system. Then we have a multi-programming operating system. In that we have a multitasking, multi-user, time sharing, and also we have a real-time operating system with distributed operating system. We'll see each one of the type of operating system one by one. So here first what we have, single user operating system. So where we can see single user operating system? In your laptops or personal computer, you can have the single user operating system. That means when the resource, all the resource, that means CPU, input, output devices, memory, everything is allocated for a single user or a single person. In order to access all those resources, then we are calling that kind of operating system as what? Single user operating system. So this OS allows only one user to share the system resource, including the CPU, processor, input, output devices, everything together considered as a resource. When it is allocated for an individual person at a time, then we can call that as a single user operating system. So mainly we are going to use this for the purpose of laptops and PC, desktop, like that. Then what is the example for this operating system? We have a DOS and Windows 95, Windows 98, Apple, Macintosh. All these are the example for this single user operating system. Then what about this batch operating system? As the name indicates, we have a batch, and this operating system will going to process, or it is going to manage the different processes. So here batch is defined as a group of job. What is batch then? It is a group of job with similar needs and similar resource requirements. So when we have a set of programs or a set of job which require serving a same need and having a similar source requirement, then we are making all those set of jobs as one batch, and we are feeding that to the computer CPU in order to do the processing. That making of batch based on the similar job will be done by this operating system, and this operating system allows the user to create the batches and execute each batch sequentially. Batch 1, batch 2, batch 3 up to batch n we can have, and processing all the jobs of batch considering them as a single process. Batch 1, batch 2 up to batch n. So together we are calling that as a single process instead of considering that as a different one. So whenever we are having a similar needs with similar requirements of resources, then we are making that number of jobs as a group, and we are calling that group as a batch, and we are feeding that to the operating system. Operating system will going to make them as a different batches, and together we are calling that as a single process. Then we can call that as a batch operating system. So mainly where we have to use this batch operating system, when there is a little or no interaction between the user and execution programs. If you take the example of Xerox machine or photocopy machine, so there at the time once I feed the data, once we are given it for printing, then in between no interaction is required between the user and that execution system, right? So wherever we wanted to have a little or no interaction, then we have to use batch processing operating system, and mainly well suited for application with large computation time and no user interaction. So for example, whenever we are checking for the weather forecasting. So when we are looking for the centimeters of rain, at the time and no human interaction is required all the time. So we can keep that operating system keep on executing all those things. At last it is going to give the resultant. So that for the purpose of payroll, forecasting and statistical analysis are the example which comes under this batch operating system or batch processing system. So here you can see that we have a different jobs, job 1, job 2, job n, and we are going to merge job 1, job 2, and I am going to make it as a batch 1. Okay, and with the help of this operating system, it is making as a different batches, and I can consider a collection of batch as what? Process. Then it is going to be handled by the CPU for the processing purpose. Fine, this is how batch operating system works. What we have next? That's all regarding multi-programming operating system. In this multi-programming, as the name indicates, more than one program or more than one set of instruction is taking place when the capability of CPU to execute 2 or more programs concurrently. So simultaneously, if the operating system is executing 2 or more programs at a time, then we can call that kind of operating system as what? Multi-programming operating system. So 2 or more programs are stored concurrently in the primary storage. So we have a job 1, job 2 up to job n. All these will going to be stored in a computer's primary memory, and CPU moves from one program to another, partially executing each in turn. So job 1 will going to be run for 2 seconds and job 2 will going to be run for another 2 seconds. So when I'm looking this, I can see that this is what parallelly taking. We won't feel that there is a gap in between the job 1 and job 2. Okay, this is multi-programming operating system. Next, what we have? Multitasking. So here task, that means activities. Multitasking operating system allows more than one program to run at a time. So whenever we are running a more than one program at a time, then we can call that as a multitasking. It is going to perform more than one activity at a time. And that means what? Multitasking, you are listening to the music, you are giving it for printing, and you are doing something with Word document. So all those are what? Multitasking. You are doing more than one task or operation at a time. And also, it gives you the perception of 2 or more tasks running at the same time. How it feels to us? We are running 2 or more programs at the same time. It does this by dividing the system resources amongst these tasks. So whenever we have more than 2 tasks, so the resources, memory or input output devices, everything will going to be distributed for each task separately. But for us, it is going to look like what? 2 or more tasks are running parallelly. But multitasking is usually implemented by code and data of several programs in memory simultaneously and multiplexing processor and input-output device among them. So in order to have this multitasking, we require this multiplexing processor along with input and output devices. And also, we call this as a context switching. Why? Because it is switching from one task to another task parallelly or simultaneously. That is why we are calling it as a context switching, and also it refers to a single user. So when a single user is performing more than one task at a time, then that is multitasking. Then what are the operating system we have which comes under this multitasking? That includes Windows 95, OS2 and Mac OS. So these are the examples. Next, we have a multi-user operating system. Multi-user, user is more than 2 here. So allows the multiple user on the different computers or terminal to access a single system with one operating system on it. So here we have a different computer system and we have a different user in order to use that computer system. But I have only one operating system that is regulating and controlling the activities of both the programs individually. Then we can say that as a multi-user operating system. So it is allowing multiple user on the different computer. So here we have a computer 1, computer 2, a terminal to access a single system. So here I have a single system, but I have n number of users with n number of different computers, but I am accessing a single computer with the help of the operating system, with the help of single operating system in it. Then it creates and maintains the individual user environment. How this individual user feel? So he feels that this is my system, this is my input output devices, are complete resource of a computer, even person to feel the same. And then individual authentication and security level privileges provides per user resource usage accounting. So for each user, every resource will going to be allocated individually, but more than 2 person accessing a same system with a single OS, but individually they are accessing. So that is considered as what? Multi-user. Then what are the example? We have a MS-DOS and Windows 9X. All these are the operating system where we can see this operation called multi-user operating system. What we have next? That is real-time operating system. As the name indicates, real-time. We can't wait for more time in order to get the resultant. When we wanted to have a instant result, at that time you can have this real-time operating system. Moreover, it is a multitasking operation system that aims to execute real-time application. For example, aircrafts. So if it is getting crashed, I can't wait it for 10 minutes, 2 minutes like that. Within a fraction of a second, the actions to be taken. At that situation, we have to use this real-time operating system. So now you wanted to go for a movie, but you are left out with only 5 minutes. But if it is taking 50 minutes in order to book the details for the particular show, then we won't use that application, right? The operating system should be very fast in order to access the content simultaneously. So in that situation, we must have this real-time operating system. Mainly it is designed to respond to an event with a predetermined time. So we can't wait much. So within that particular time of seconds, it has to be executed. Then these operating systems are used to control machinery, scientific instruments and industrial system. And it is very little user interface capability and no end user utilities. It is not user friendly. You can't use it simply. So in the scientific instrument and in the for this we require some sophisticated user. The user must be very informative, or they must have certain knowledge in order to use this kind of operating system. Example is what? Linux operating system. Fine. So here you can see that where and all can we have this real-time operating system, where we require higher and timely response. The response time should be very low, but timely response is required. And then these are used like medical imaging system and industrial control system, reservation system. If you are trying to booking for a train or airlines, if it is taking too long, then we won't use that kind of application. In order to make it very versatile and very fast, then we have this RTOS. Then Linux operating system is an example for this one. I hope you all understood regarding this real-time operating system. So at last here we have a distributed operating system. So what do you mean by distributed here? When the data can be stored and processed on multiple locations in a different computers, when we have a same data which will going to be stored in a different location. So this distributed operating system uses the multiple central processor to serve multiple real-time application. So you got to know regarding RTOS, or a real-time operating system. When I have a collection of real-time operating system, then I can say that as what? Distributed operating system. So it has a multiple CPU to serve a multiple real-time application. So reservation is not only meant for Mysore. Also I have a Bangalore, Dharwad, Hubli. So where and all we are having that RTS together, the data is distributed among the different CPU. Then we can have a different real-time application. And then this is going to manage as a group of independent computers and makes them appear to be a single computer. Anyway, it is managing a group of individual computer, but it seems like what? They are managing a single computer system, and data processing jobs are distributed among the processor according to their efficiency. Based on the efficiency, the program or a set of instruction will just going to be distributed in order to do the processing. And the processors other through various communicate with each other communication lines. With the help of this communication line, the processor will going to communicate each other computers or individual system here. The process result are later compiled together on a central computer. So if you consider like this, this is one of the distributive system, and all these are connected by the computer lines or internals bus. Then when we got the resultant, in the main CPU, everything will going to be processed at last, compiled and processed at last in the central computer. Then it is going to give the resultant. Fine. That's all regarding what? Distributed operating system. I hope you all understood my today's session. In our coming session, we're going to see or focus on this Unix operating system. Let me meet you there. Until that, keep learning, keep on growing. Thank you.